Hello everyone, and thank you for watching this video. Today we are discussing how to approach migrating a retail-based application from an on-premises VMware environment to Azure. This migration involves a large infrastructure of 3,000 servers. These servers include a mix of Windows servers running versions from 2019 and above, Linux servers running Red Hat, and critical infrastructure services such as Active Directory, DNS, certificates, and firewalls. This customer is new to Azure and does not currently have an Azure environment. This migration journey starts with planning and preparation, moves through setup and migration, and concludes with optimization and management. Let us break this down step by step in simple terms. Assessment and discovery. The first step is understanding the current environment. This involves gathering information about all the servers, their workloads, and how they interact with one another. Using Azure Migrate, we perform a detailed scan of the VMware environment. This tool helps us gather technical information about the virtual machines, such as the operating systems they run, the applications installed, and how well they are performing. It also identifies dependencies, which means we learn how different servers are connected and rely on each other. For instance, the payment processing system might depend on a database server, so these connections must be carefully documented to ensure nothing breaks during migration. We also work closely with the customer to prioritize workloads. Business critical applications, like the ones used for customer transactions, will take priority, while non-essential systems can be moved later. Strategy and design. After the discovery phase, we plan how to migrate each workload. This stage focuses on determining the best approach for every application, service, and system. For most servers, we will use the lift and shift method. This means moving them to Azure without making changes to the applications or the operating systems. However, for some systems that could benefit from modernization, we may use other strategies. For example, a large and complex application could be replatformed to run on Azure Kubernetes service to improve scalability and efficiency. For core infrastructure services like Active Directory and DNS, we set up hybrid connectivity. This allows the on-premises services to continue functioning while extending their capabilities into Azure. Active Directory will be extended using Azure AD Connect, DNS configurations will be replicated, and certificates will be securely stored and managed in Azure Key Vault. A detailed timeline is created at this stage to ensure the migration happens in phases and avoids disrupting the business operations. Building the landing zone. The landing zone is the foundation of the entire Azure environment. This is where the virtual machines and applications will live after the migration. Building this foundation properly is critical for a successful migration. The landing zone includes key elements. Identity and access management is implemented using Azure Active Directory. This ensures that only authorized users and systems can access the environment. For enhanced security, multi-factor authentication is enabled. Networking is configured to ensure servers and applications can communicate securely. Virtual networks act like private highways with built-in protections like network security groups and firewalls to prevent unauthorized access. Governance and compliance policies are implemented to ensure the environment is well managed. For example, these policies can enforce encryption on all data storage and prevent resources from being deployed in non-approved regions. Cost management tools are put in place to help monitor and control spending. Alerts are configured to notify when spending reaches certain thresholds, helping to avoid unexpected costs. Monitoring and security tools such as Azure Monitor and Microsoft Defender for Cloud are set up to keep an eye on the environment. These tools help detect and respond to potential threats and provide visibility into system performance. Backup and disaster recovery solutions are implemented to protect critical data. Azure Backup ensures regular data backups, while disaster recovery plans use failover configurations to keep systems running during outages. This landing zone is designed to provide scalability, security, and cost efficiency, ensuring the environment is ready to handle the migrated workloads. Pilot migration: before migrating all 3000 servers, we start with a smaller test migration. This is called a pilot migration. It helps us verify the process and confirm that the tools and configurations work as expected. By starting small, we can identify and fix any issues before the larger migration begins. Full-scale migration: once the pilot migration is successful, we proceed with migrating the rest of the workloads in phases. Business critical applications are moved first, followed by less critical systems. Each phase is carefully monitored to ensure smooth transitions. Post-migration optimization: after the migration is complete, we focus on optimizing the environment. This includes fine-tuning performance, improving security, and implementing additional cost-saving measures. Applications that were lifted and shifted can be modernized over time to take full advantage of Azure services. If you are looking to gain hands-on experience as an Azure Administrator, Azure DevOps Engineer, or Azure Architect, we invite you to join our Enterprise Cloud Expert program. This program is designed to provide you with the right guidance and support to become a strong cloud professional. Whether it is understanding real-world scenarios, building your skills, or preparing for interviews, we will help you achieve your goals and succeed in your career. Thank you for listening, and I look forward to seeing you in the program.